Thanks for joining. We are going to start section number 2. Today is day number 7. You can see here the content within section number 2. In 2.1, you can see mostly it is switching. And few of the questions you have asked me earlier that what type of switch port mode we have supported in these switches like access, trunk, native VLANs, default VLANs, etc. So all those things we are going to learn, and then we have to perform the lab task as well. So 2.1, 2.2 related to basics of switching technique, then 2.3 basics of discovering the switches. You can see CDP, LLDP, and then 2.4 is a very interesting topic that is related to EtherChannel, bundling the port, then a spanning tree protocol, then within a spanning tree protocol, different type of ports and their use, why we are using that. Then little bit of wireless related to wireless architecture, APs. Then security, a small topic related to, actually not exactly the security. This is related to device management because in section 5.0, entire section 5.0 is related to CCNA security. And finally, you can see that we have to understand about the QoS. So what I have done, I have split the chapters within different days. So today we are going to learn only 2.1, 2.2, and if time permits, 2.3. 2.1, 2.2, we can see the topic that access port, default VLAN, InterVLAN. Then 2.2, you can see the topics related to trunk port, 802.1q, native VLAN. And then finally, how we can go and discover the switches. We have to understand about protocols such as CDP and LLDP. So let's start. Let's start with these topics that we are going to learn today related to 2.1, 2.2, and 2.3. Switching topic and how we can go and discover the switches with protocols such as CDP, LLDP, right? So here we can see, you can see here that we have the topology, the same topology that we are using in our previous sessions as well. And these switches are connected with these interfaces. What we will do today, that suppose we'll go and use only one interface. Suppose they are connected with E10 and E13, Ethernet 1.2, Ethernet 1.2, Ethernet 2.0 and 2.0. But since we want to learn little bit about the connection that is going towards the host PC as well. So let me go and draw here this diagram. First of all, I'll explain you everything and then we'll discuss more about that. So in this switch, in this access switch that you can see, switch number 110, in this switch number 110, if I go and connect two laptop or the PCs, so the diagram will look like this and like this. And suppose these workstations, this PC is E0/0, and I'll go and use VLAN 2000, and then E0/1, I'll go and use VLAN 2001, like that in our topology. So if you see this diagram, you'll see that, okay, you have access switch. So this switch you can refer as access switch. Why? Because it is connected with the workstation. It is connected with the PCs, and then you can see that they are connected with some distribution switch. Suppose this is distribution 1 and this is distribution 2. Why? Because again, these access switch will connect with distribution switch will go and connect with the core switches or core routers that we'll discuss in the upcoming session. Because after these switch 101 and 102, obviously we have some more connectivity. And later on in this class, you will see that we have some routers connectivity like this. Routers are connected like this, and these routers have back-to-back connectivity. Later on, we'll learn more on the routing section. So let's focus on this diagram that we have related to switches. So you can see that we have the access switches, switches that is connected with the PC1 and PC2. They are termed as so those ports are termed as a access port. So let me go and categorize the ports here. So these ports that you are seeing E00, that is nothing but the access port. Access port means that at a time these ports having one VLAN. So access ports means that they will connect with access VLAN, and access VLAN means at a time they can pass only one VLAN. So in our case, you can see that we have access VLAN 2000, 2001. So that means that if I have my switch, so let me go and pull my switch. And somewhere here. So if I go here to this particular switch, switch number 101. Let me clean the okay. Okay, so you can see my switch number 101, and if I can access this port, switch 101, okay. So what you need to do, if you go to interface E0/0, first of all, you need to create VLAN, say VLAN 2000. Suppose this is sales. So you can give the name, suppose sales, and VLAN 2001, suppose this is the name, marketing. Now you can go to interface 00 and you can do switch port. First of all, mode access. So this interface will pass only one VLAN at a time, and then switch port access a VLAN 2000. Likewise, you can go to interface E01, switch port mode access, switch port access VLAN 2001, 0/0. You can see the configuration over 00 and 01, that how we are configuring these switch port mode access, switch port access VLAN 2001. So that means that these PCs, they are part of only one VLAN. That's the meaning of what? That's the meaning of access VLAN. So this is one type of VLAN that you can see here in the diagram. But you can see that here we have VLAN 2000, here we have 2001. But over this interface, suppose over this interface E1/0 or over E1/3, you want to pass 2000 and 2001, that should go to the distribution layer switch. So that means you have to go to these interfaces and you have to make this as a trunk. So while making that trunk, you need to pass one protocol 802.1q. That should be the encapsulation. Encapsulation should be 802.1q, and then once you are making certain ports as a trunk, they will pass. So let me write here. So if some port that we are making as a trunk means passing multiple VLANs, and then we have option that we can allow or disallow number of VLANs. In other words, you can filter the VLANs. So over this trunk, so we know that by default everything is permitted, but over this trunk it's optional, like we can go and allow. So we can go and allow trunk for VLAN 2001, 2000, 2000, 2001. Suppose if you have 20, 30 different VLANs, but you want to pass the information related to VLAN 2000 and 2001, you have that option. You can go and do that. So what I'm telling here is this. Let me go. Oops. Let me go and pull the switch. So here we are. And clear my drawing. So here we have this switch here. And what are the interfaces? Interfaces you can see E10 and E12. So over this particular switch, let me first of all default the interface, because there are certain configuration E1/0. Okay, so over this interface, what I want, let's go to E1/0. First of all, switch port mode trunk, what it will do. So see, at the moment I'm typing this command, it is telling that command is rejected because you have to go and make the encapsulation as a 802.1q. So switch port, first of all, you have to go and do switch port trunk encapsulation .1q and then switch port mode trunk. These commands, switch port encapsulation and trunk. Now, switch port trunk allowed VLAN. I can see the options we have: add, all, accept, none, remove. So what I want to do here is this: allow VLAN, and I want to allow VLAN 2000. For example, I'll give 2000. Let me show you that. So now you can see that over this interface, I have one VLAN allowed. So I just wanted to allow VLAN 2000. But suppose if we want to add 2001 as well. So for that we have option allow VLAN add. VLAN add 2001. So now if you see this configuration, the output, you can see that you have added something. See, either you can go and use the allowed command and you can go and add allow VLAN 2000, 2001, 2003, or you can go and give the range command, or you have this statement and after that you want to add some VLAN, you can use the add command. After that you want to remove something, you can go and use the remove command. So likewise we have options: add, remove, no VLAN, accept. Like that you can go and play around with this. You can manipulate the configuration with this. Now if one side is trunk, the other side also you should go and make this trunk. So let's go ahead to the other side of the switch. Default interface E2 slash, what is that interface? E1/2 and 1/3. Okay, no problem. E1/2 and 1/3. So I can go to interface E1/2. See, switch port trunk encapsulation .1, switch port mode trunk, switch port trunk allowed VLAN, suppose 2000 and 2001. I'll give both E1/2. You can see that at the moment with the same single command we have added two VLANs over the interface. Likewise, you can see that we have interfaces E1/2, E1/2. So I can go here. First of all, I want to default the interface E1/2, and then I'll go to E1/2 and I can paste the same configuration. Then you can go and check do show run interface E1/2. Then I can go to this side of switch. Default the why I'm defaulting, because they have some default configuration that I don't want. I just wanted to add my configuration E1/2. So you can see. So what we have done that we have created the access VLAN. We have created the trunk. Over the trunk, over these trunks, we have allowed pass some certain VLANs as well that we have created here and passed to these trunk interface. So let's quickly go and see this theory that we have in the slide. Your objective is to create the VLANs and configure these switches. Okay, so here you can see you can go and use the VLAN sales 2000 marketing. I have used marketing, but you can give any name, engineering. Then you can go to interface. I used only one interface that I made as a trunk, and then I have made as a access. Likewise, switch 101. Switch 101 also I can go and create the VLANs, sales and marketing, no problem. Let me go and do that configuration to switch 101 and 102 related to VLANs. So what I can do here, I can go and check the do show history. And in the history, they have the history of 20 commands. So I don't have that. Okay, no problem. Do show VLAN. With the do show VLAN, you will get to know the name of the VLANs. So here you can see that we have VLAN 2000 and 2001, but I want that name as well. What's the name? Sales and marketing. Okay, so I can go here, say VLAN 2000 name sales, 2001 name marketing, do so history, sales and marketing. I can go and give any. So likewise, you can see in the back that we have the sales and marketing we have created. Then the other switch also we have configured the access and the trunk modes and all those things. Now the verification command, show VLAN brief, show VLAN brief, show interface trunk. So these two verification commands that we can go and run. What are those? Those commands are very easy. Show VLAN brief and show interface trunk. What are those commands to verify this? Show VLAN brief, right? And then you can check show interface trunk. It will tell you that which is the trunk and non-trunk and all those things. Let me go and maximize this here. So you can see that which ports are trunk and which ports are access, everything it will tell you, right? So far, if you have any question, please feel free to ask.
I have one only. I know that you mentioned that, but just to have like more refresh on what is the encapsulation that you mentioned, the 802.1Q, that it is on the previous. Yeah, what was that?
So
Yeah,
let me show you that about the
yeah, that one.
encapsulation. I'll show you that. I have one slide for that. So let me. Here are the configurations and it is coming twice. These things we have already done this configuration now. I have that 802.1Q slide. I'll go there. That is actually here in 2.2. So let's understand about this 802.1Q. What exactly it is. When we want to make pass multiple VLANs, so at that time we have to go and make those interfaces as a trunk. But while you're making these interfaces as a trunk, you have to pass the encapsulation. Actually, this is one of the protocol. 802.1Q is obviously the encapsulation, but trunk is a protocol which is using this 802.1Q standard to allow multiple VLANs over the interface. So here you can see that we can go and allow this multiple access VLANs over these interfaces. For that, we have to go and make the encapsulation as a 802.1Q. So here you can see the definition. 802.1q in the trunk port configuration. Actually, it is something that if you want to allow multiple VLANs, then you have to go and make that encapsulation at as a 802.1q or .1q.
Okay. So to get the idea, so the access mode is for endpoint devices or laptop PC, and the trunk mode will be like to connect to switches or network devices, right?
100% right. Yeah. So for networking devices, if you want to pass multiple VLANs, we have to make this trunk. Anyways, to interconnect the devices, we have to make it trunk. And for workstation PCs, we have to make as a access those interfaces, because those are the terminating devices. They are not going anywhere. So we'll not make those ports as a trunk. Those ports we want only to pass single VLAN. So these interfaces should be access, and these interfaces should be trunk.
Got it.
Right. All right.
I got a question. I got a question about this. Two questions, in fact.
Yeah.
One, what is the purpose of the objective to put a native VLAN?
I'll come
What
to
is
that.
the purpose to do
I'll come to that point.
that? Okay. And the other one, before you go to the next topic, um, you see that is allow VLAN, and we have an option to put known. So if we put known VLAN allow, what is then is the purpose to have a trunk port? In which cases we use a non for a non VLAN allow?
Yeah. So
You know what I mean?
use cases will be there that you don't want to pass any VLAN. So you can go and make this as a none. Oh, these things are there while doing some sort of troubleshooting. You can make this none, just make sure that nothing is passing via those interfaces. Troubleshoot, and then you can revert back the configuration.
Okay. Because I got it all the other options is except or all or whatever, but the non I don't. I
Yeah, means
can
it's
think about
like
for a case use.
pass everything or block everything for certain period of time. It's
Okay.
something that you're blocking the traffic just to
Okay.
make sure that things are okay, and then you can go and revert back the configuration, because the idea here is to pass the traffic, pass the
Mm-hmm.
multiple VLANs. So
Mm-hmm.
obviously you have some servers, some more different VLANs you want to pass via the trunk interface. And for
Mm-hmm.
that purpose, you are creating a trunk. Now over the trunk, we
Okay.
have options like none,
Okay.
all, accept, remove, and you don't want to disturb the traffic. So you can go and selectively remove the VLANs or add the VLANs. So those options we have. Sometimes these commands are very critical when you're passing some server information, and you simply can't go and break that trunk information. Otherwise, the services will stop. So on those cases, you can go and add small commands like add something or remove one or two VLANs like that.
Okay. Okay. Got it.
All right. So let's go one by one. We have that information about native VLAN. What does it mean by native VLAN? I'll come to section 2.2. Let's say that what we have studied. So in 2.1, we have topics to understand the data and voice VLAN, default VLAN, and inter-VLAN connectivity. So let's understand these topics, and then we'll understand about the native VLAN and 802.1q, etc. in 2.2. Data, so far the configuration that you have seen, that is related to data. That means that assuming that you have the ports connected with the, you can see ports connected with the workstations or PC where you are making this as an access. But if you have some IP phone connected, so in that case, what you will do, you'll go and create VLAN. You can see VLAN, name of the VLAN, like VLAN ID, and then name voice, VLAN ID and name voice. You can see. So we can go and add a small piece of configuration as well. And if you go and create this voice VLAN, so obviously you want to add over the VLAN, over the trunk interface as well. So what I'm telling here is this, that voice VLAN is also a type of VLAN, but the purpose of voice VLAN is to pass the voice traffic, right? So I can go here, I can create VLAN. So for example, VLAN 100 and name voice, and then I can go to the interface, which is my interface. So let me go and check the trunk interface, E1/2, right? So I can go to interface E1/2 and I can go and add switch port trunk allowed VLAN add 100. E1/2. So now you can see that we have added one more VLAN, and this is for voice VLAN. We have added the voice VLAN. So like that, we have the purpose for these VLANs. And now obviously we know what's the use of the trunk. So you can see data and voice. You can go to the interface and you can go and over the interface, if you have some PCs like PCs that is connected with IP phone, or IP phones can be directly connected to the switch interfaces where you want to make as a voice VLAN, you can make it. Even we have the command switchport voice VLAN. You can see switchport voice VLAN. So the configuration here is this: switchport mode access, switchport access VLAN 100, switchport voice VLAN 100, right? This configuration you can do, no problem. We have done all this configuration. Great. So 2.1b, what is a default VLAN? So once you have a switch, so suppose if I have a switch, I purchase one switch from Cisco, and this switch by default, all those ports in this switch, they will be part of some default VLAN that is nothing but VLAN 1. So at the moment, these switches, you can see these are the interfaces. By default, they are part of one VLAN, and that VLAN is nothing but VLAN 1, and this VLAN 1 is nothing but the default VLAN. So later on, what we can do, you can go and group these interfaces. Some of these interfaces, they are part of VLAN 10. Some of these interfaces, they are part of VLAN 20. Some of these interfaces, they are part of VLAN 30. So like that, you can go and segment the broadcast domain. But what's the problem? What's the problem if you go and make a segregation? So suppose some of the VLANs, they are part of VLAN 2000. Some of the VLAN, they are part of VLAN 2001. And some of the VLAN, they are part of voice VLAN. So if you go and make such type of segregation, then these VLANs, they are part of different broadcast domain, right? By default, they are part of what? VLAN 1. But after some configuration, what you have done, you have moved those interfaces within different access VLAN, right? So now your interfaces, some of the interfaces are belonging to access VLAN 2000, some belongings to access VLAN 2001, some belongings to access VLAN 100, right? So here access VLAN, access voice VLAN 100. So here point is this, that now these VLANs, they may have different type of IP addresses. These VLANs, because you are segregating the broadcast domain. So that means that if I have one PC here, so what I'm telling, suppose this PC here, suppose this is PC1, this PC having IP 10.1. Suppose 20.1, or maybe suppose 10.1 or 10.10, and PC here having IP 10.1, 20.10. So you can see clearly that this is different network and this is different network, right? So if you have two different network in same switch, by default, they will not communicate to each other. So on that case, you have to go and configure InterVLAN connectivity. So that means that you can go, you have multiple options. That means we can go and create the switch virtual interface, or you can go to the router. Suppose this switch is connected to the router. So let me draw here. Suppose this switch is connected with the router like this. Over this router, you have to go and define the gateway for this network and this network, and this router, if some PC has to go and ping to each other, so this router will provide you gateway. So traffic will come like this, go to the router, and it will go to this. This will be the movement of the traffic. Now, in case you do not have router, suppose you don't have the router, right? Then how you will do this? Then in that case, you have to go and create the SVI, Switch Virtual Interface 2000, and Switch Virtual Interface 2001, where you have to go and define the gateway 10.1.10.1 and 10.1.20.1. These are the gateway. So the traffic, again, the movement of traffic will come from this PC, go to one SVI, from one SVI it will go to the other SVI, and from that it will go to the destination. So that routing thing will happen within the switch itself, within the switch control plane itself. From one VLAN gateway, it will move to other VLAN gateway and reach to the destination. Now here in the example in the lab, you can see that switch 110, I am making this as a gateway. You can see interface VLAN, this IP, interface VLAN, this IP. I'll not go and use this IP. Let's go and use the simple one, 10.1.10.10.10.20.10. So what I'm telling, let me go and pull my PC. So suppose I have host 1 and host 2. See, we know that is the IP address 10.1.10.10 subnet 25. Suppose this is one of the workstation that is connected with interface with switch 110 over the interface E00 and E01. Like that, we have the connectivity. You know that connectivity diagram. Now default gateway is 10.1.10.1. Where you will define this gateway to switch 110. Likewise, I have to go to this host number 12. Say interface E00 IP address. Here you can see IP 10.1.20.10 and no IP routing and IP default gateway 10.1.20.1. Oops. Okay, so now you have two PC 11 and PC 12. One PC, you know that the address is 10.1.10.10. So if I go here and try to ping 10.1.20.10 from 10.1.10.10, they will not ping. Why? Because this is different network, this is different network. Although they are connected with same switch, right? Although they are connected with switch 110, these two PCs, but you have to go to the switch and you have to create the SVI. So what we'll do, we'll go to the switch 110 and we'll create the switch virtual interface and we'll define the gateways there. And after that, you will see that they will ping. Let me give the repeat counter for 1000 times and let's go here to the switch 110. See interface VLAN 2000, IP address 10.1.10.1 255.255.255.0. Interface VLAN 2001 and IP address 10.1.20.1. Now you can see do show IP into brief. So you will see that your SVI is having the IPs, and if you go here you will see that these devices will ping. You can see bottom there is one more command, IP routing. I should go here and do IP routing. Make sure that these VLANs can communicate, these SVIs can communicate to each other. And now they should ping. They are not pinging. That means that you can go and check your gateway first of all. 20.1. Are you able to reach to your gateway? Let me go and check. So first of all, these PCs should ping to their gateway and then only they will go and reach, right? So let's see. /0 switch port mode access. That's correct. You show IP interface. If these interfaces are up or down, 0, 0, and you can see up, 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 up. They're up. Then from host, you show IP interface. Let's see the interfaces here. Oh, down. What about 0, 0? 0, 0 is up. E is 0 slash 0. Let's see that. Interface E0 slash 0. Taking time to duplex. Maybe we have some 10.120.10 section 4. Let's see, something is wrong. It is not pinging to its gateway. First of all, it will reach to the gateway. 10.120.1 no IP routing. 10.1.20.1.
The SBI are down, no, Rakesh?
SVI is down. We'll check that. Let's go to 110. Let me clear the brand. Oh, SPIs are down. No shut and no shut. Oh, now you can see it is pinging. Okay, thanks for letting me know because it was hidden actually with the diagram. So I was not able to see the SVI status. It was here. Okay, so now if you go back here, you can see it is pinging. That means our inter-VLAN routing is working, but how we will verify and test that? First of all, try to reach your gateway and then to the other side. Suppose if you have any issue, you can go and ping to your gateway first, like we tried to reach to the gateway from where we figure out that the SBI was down. This was down actually, it was hidden by this diagram. Now it is up. Since it is up, we can reach. So we can ping to the other locations. This is the concept called inter-VLAN routing. Different VLANs, you can assign the L3 addresses and they can ping to each other. Any doubt on this lab? Please feel free to ask.
No questions.
No, I'm okay.
All right, great. So let's move on. Let me clean this stuff. You have verification. So VLAN brief, trunk, status, and all, and then you can do the ping testing. You can verify it. So what we have studied so far, we have the VLANs. Actually, we have the VLANs, and you have the normal range VLANs, and you have extended range VLAN as well. Surely that will come in the upcoming section. So you have the access port, you have the default VLAN, and then we have done one lab related to inter-VLAN routing. Then the Trunk ports, you know what is the trunk port? To pass multiple VLANs, you have to make that as a trunk. But the encapsulation for trunk port is nothing but 802.1q. And then we have the concept of native VLAN that I will go and cover. How you can go and configure, you can see the entire configuration. You have to go and make this encapsulation.1q. Then you have to make this as a mode trunk, and then you can go and allow multiple VLANs. We have native VLAN as well. I'll cover this. This is nothing but the untagged VLAN. Why we are using it, we'll discuss. So you can go and do the configuration. After the configuration, you can verify this as well. There is one verification command, show interface trunk, that will give you. This is very good example that, you know, the verification command example, that once you do the configuration, you can go and run this particular command, and then you will get the information. This will give you robust information about the trunk access and trunks and different type of port information. I may have this show VLAN brief output is there, show VLAN brief output is there, but I can go and run this command. I'll run this command. I'll show you the output one more time. Now 2.2.c, you can see that native VLAN. So we are setting the native VLAN. Why you are making this native VLAN? I should give some article as well related to native VLAN. Have I added some theory as well? I don't think so. I should add some theory. Let me see that I have the chart. Okay, so I haven't added the chart. Generally, you'll see in the upcoming sections that different type of features that you have. I have created one table. In that table, you can go and compare different type of features. Here I haven't added, but native VLAN is nothing, but it's like untagged VLAN. So that means, see, whenever, let me go and explain you with a diagram, otherwise you'll not understand this concept. Let me draw it. Suppose this is my switch, right? And this is suppose PC1 and PC2. And it is connected with one port here, it is connected with other port here. Now, when you are creating the VLAN over the interfaces, what exactly you are doing? You have something called tag, you know, some marking. Tag 2000, tag 2001. Now, when the traffic, so what will happen that the traffic flow, let's understand the traffic flow as well. So here, if the traffic will move from this PC to this PC, how it will be? It will start with VLAN 20, obviously. How it will get the VLAN 20? So when the traffic will come and hit this port, suppose port 00, then switch will go and put some encapsulation. It will go and put some tag value 2000, right? Now your frame having one extra encapsulation, one extra tag of 2000. Now, since you know the destination, but when you move to the destination, that destination, what tag that destination has? So it will go, so this is marked as a 2000, but it has go to 2001. So once this traffic will come here to this interface, what this interface will do, what this switch will do, this will go and put 2001. So the traffic that is coming, oops, one second, let me revert back the image. So the traffic that is coming with VLAN 2000, It's a very important concept. The traffic that is coming with VLAN 2000 over this interface will go and put the marking 2000, right? So this PC having IP suppose 1.1, this 1.1 here you have the tagging, marking, put the mark 2000. But will this PC understand 2000? No, right? This PC will not understand 2000. What this PC will understand? This PC will understand 2001 only. Why? Because this port is part of 2001. So that means if someone is coming with 2000, he has to go and remove 2000, remove that 2000 tag, and then what he has to do? He has to go and add, the switch will go and add 2001, and then this PC will understand only 2001 because this PC is part of 2001. So you can see the tagging and untagging of VLAN is happening. See, if you are in VLAN 2000 and if you are communicating with the PC in same VLAN, then in that case tagging and untagging will not happen because you are part of same VLAN group, VLAN 2000. But if you are in VLAN 2000 and if you have to go to VLAN 2001, behind the scenes switch will do the tagging and untagging provided that we have created the SVI locally, not over the L3 interface or a L3 router. We have the local SVI here. So tagging, untagging will happen. Now, if you don't want to do this, right? If you don't want that this tagging and untagging will happen, so you can go and use the concept of native VLAN. Native VLAN means that you are sending, so once, suppose I have native VLAN 100. So let's check the example. Suppose this is one extra PC I connected here. Now this extra PC you can connect anywhere, and this extra PC having tag value suppose 100. Now what we have done, that this tag that we have native VLAN 100 tag, that means that it is actually untagged. Now this 100 VLAN 100 can go anywhere without encapsulation, without decapsulation. That's the whole idea behind the native VLAN. So what will happen? These systems, they will think that VLAN 100 is its VLAN. It's a native to me. It's my VLAN. Because native VLAN itself means that you are not tagging or untagging. That's why we are using the concept of native VLAN. Okay, and in our example, this native VLAN is part of voice VLAN 100. Yes. In simple word, you don't want to tag, untag, so you are using native VLAN. Native VLAN means that they are not tagging, untagging the VLANs. That's the use. All the PCs, they will think that they are part of the same VLAN. They are native, like VLAN 2000, 2001. Everyone will think that 100 is my VLAN, because remember one thing, it's very important to understand this concept. You have switch, right? And you have PCs. Now these PCs, they do not have VLAN. Where you have the VLAN? You have your VLAN over the interface. Over the interfaces where they are connected, right? Over the interfaces where they are connected. So who will do the tagging and untagging? Switch will do the tagging and untagging of the VLANs. So if you have some VLAN that you don't want to tag and untag, you can move them as a native VLAN. Okay, I hope you understood this concept. If you have any doubt, please feel free to ask.
But like, why use native VLANs? Like, what will
For
it be the case if
voice traffic.
sorry?
Voice traffic. In our case, we have used for voice traffic. We don't want,
Okay.
so your IP phones may be part of any access VLAN. So there you want to go and use it.
Okay. So it's like for compatibility or some sort of
Yeah,
that?
you don't
Like,
want to give extra overhead, so you can go and use the native VLAN.
oh, okay. Got it.
All right, so we are doing good. Let's move on and let's see where we are in the agenda. So we have learned a lot, and you know we have approx 30 to 35 slides related to this access VLAN and this VLAN and trunk VLAN and encapsulation, native, 8021Q, InterVLAN routing and all those things. Your task is this, that in your own time you will go and check these documents and you have to perform the hands-on task, right? You have to perform the lab. All right. So finally, for today's session, we have one very small topic related to discovering the switches in the network. Now we have two different protocols to discover the switches, routers, networking devices in the infra. For that, we are using either Cisco Discovery Protocol, CDP, or LLDP, Link Layer Discovery Protocol. CDP and LLDP, these are two protocols that is used to discover the devices within the network. Now these protocols, you can go and turn it on globally. So you can go to conft CDP run, conft no CDP. So you can turn it on or off, on, off. Or you can go to the selected interfaces and there also you can enable it. But to enable over the interfaces, obviously you have to enable it globally. So enable it globally and then you can go to the interfaces and selective interfaces, you can go and run it. Once you go and run it, then what these protocols will do, they will go and learn the neighbors, connected neighbors, not only the connected neighbors information, but they can go and learn the detailed information related to device ID, IP address, platform, capabilities, right? In our automation, you know, we are using such type of automation to, first of all, enable these protocols, and then we are parsing the information. So I have the information related to source CDP neighbor detail. I'll show you that in the lab. This is very big output. It will give you information related to ID, IP, platform capabilities, but what you want some 2-3 important key points within this big output. So you can take this output as a JSON format, or you can take this output and then you can convert in a presentable format with help of Python. So those tricks and techniques you can do. Even these inputs can be useful for automation server that can go and build the entire topology. That is the good thing about these protocols, right? The bad thing about this protocol is this, that if you go and enable these protocols, then your network visibility will be there. Obviously, your network visibility will increase, but that is one type of security threat as well. So it is very important that if it is required, enable it. If it is not required, then do not run these protocols. Otherwise, someone can go and learn your network, right? So both ways means you want to enable these protocols or disable these protocols. Obviously, in a production network, you will not see these protocols are enabled. Now, there are dependency on the CDP protocol related to voice technology. The IP phones or the IP telephony networks, they need this CDP to enable. So on those cases, you can go and enable this as per the requirement. If it is a requirement for some other technology to discover the network, to understand the network, then you have to go and enable it. But by default, it is not enabled over the devices. It is not recommended to enable the CDP LLDP protocol to all the networking devices in the infra. If you want to discover, you can turn it on. Later on, you can go and turn it off. So like CDP, you can go and enable LLDP protocol, link layer discovery protocol. You can see LLDP run, no LLDP run, and then you can go over the interfaces. Not only you can go and enable the LLDP, but you can see that we have the option LLDP transmit, LLDP receive. We can go and enable these features as well, that you want to send, you don't want to receive. Like in CDP, you don't have this option. CDP is Cisco proprietary, Cisco protocol, where you have to go enable the CDP, and then you can go and enable over the interfaces. That means you are sending and receiving. You are doing the both. You are sending the CDP, you are receiving the CDP. But LLDP, that is the industry standard protocol, there you just want to transmit or just want to receive, you have option. You're sending the information, you're not receiving it. If you want to receive it, you can go and enable the receive option as well. And then you have option show LLDP neighbor, like show CDP neighbor detail. You have this option show LLDP neighbor details. And then you can go and verify this. So let me quickly go and run this protocol over switch 110 and switch 101. Let's start with CDP. So CDP run. Then interface E, what is that interface that is connected? 10, right? Let me check. Do show run interface E1/0, where we have done some config. Yeah. So over this interface, CDP enable. Likewise, I can go here. CDP run global configuration E1/interface E1/2 CDP enable. Now you can check do show CDP neighbor brief. So brief command is not there, but this means brief only. Show CDP neighbor. You can see that it is learning 2020. Wow. So not learning that what we are sending. It is learning only switch 101 on 102. Interesting. And you can go and do the details as well. Details. Let me do this. Show CDP neighbors details or detail. So you can see that it is learning the full-fledged information, full information about the switch that is connected. But I'm not learning 110. I should learn 110, right? I'm learning 102. Why? Let's see. Show CDP neighbor. It is learning host. It is not learning switch 101. Wow. So what are the interfaces that is connected from switch 110 and 101? It should be up and running. E1/ I think 1/0 and 1/1. Actually, some port channel and other things are there. Let me do one thing. Default E1/1 and CDP. We should go to interface E1/1. CDP enable. Likewise, I should go here. Interface, sorry, that interface E1/. Let's see. To show run interface E1/1. It is not connected 1/2. It is connected 1/2 and what about 2/0 and okay, so 1/1 and 1/2. I think it is connected. So interface E1/1. CDP enable. Do show CDP neighbor. Do show EtherChannel summary. Some EtherChannel configurations are there, you know. Mm, mhm. 1/1, 1/2, interface range E1/1 to 2, CDP enable, to shut, to show CDP neighbor, and there also. So, you know, this is good actually that it is not discovering. Now, if it is not discovering, if I go to interface, you will see that port is in the error disable mode. So if I go here, show interface E1/1, you will see here that this port, now it is up and running. This port, it is connected. If it is not discovering, if you go to that interface, you will see that port is in the error disable mode. That's why it is not discovering. 1/0, because if it is a connect, see, error disable. So if it port is in error disable, then you have to go and do shut and no shut to clear that error. And then if you go and check this CDP, now you will see that you are learning 101. Now if you go here and see show CDP neighbor detail or show CDP neighbor, just to show you the summary, you can see you are learning 110, right? Because port was in error disable mode because of inconsistencies in the configurations and port channel and prior configurations. It moved to error disable, that you have to go and fix it. Now, these are very much, you know, real life issues that you may face while doing the configuration or removing the configuration. So this was related to what? This was related to CDP. Likewise, I can go and turn this off. So CDP, no CDP run, right? So that means we are removing that CDP. 1/0 no CDP enable, gone. Likewise, I can go and do no CDP here as well. No CDP run and interface range. What was that? 1/E1/1 to 2. Okay, and now if you do to show CDP neighbor, see, CDP is not enabled, so we are not discovering the port. Why? Because this time we want to enable LLDP. And then interface E1/0, LLDP, what was that? LLDP receive, transmit, LLDP, receive, do so history. Just to copy this configuration, LLDP, but not over this interface. Our interface here is different. Let me run this. Interface is what? Interface is E1. Let me take the range. And in this interface, I want to transmit and receive. Now, if you run such LLDP command, then you can go and verify this like this. Show LLDP neighbors. So now we are discovering via which protocol? Now we are discovering via LLDP protocol. And then the detail as right. So that was the topic related to LLDP and CDP. Have you have any query? Please feel free to ask. Thanks for joining. You can see the agenda for today's training. Today we are going to learn about the EtherChannel port channels. And specifically in that, we have to learn about the protocol LACP. Although we have multiple protocols to bundle the ports, we have industry standard protocol, that is LACP, And then there is one Cisco proprietary protocol as well, that is PAGP. But since we are following the agenda, so we will focus on LACP, Link Aggregation Control Protocol. That's the LACP. After that, you can see that we have topic related to spanning tree protocol, STP. And in that, we have to understand the basics of rapid PVST plus. Although, again, there are multiple different type of STP, spanning tree protocols, such as normal STP. Then you have the rapid PVST. Then you have rapid PVST plus. Then you have MST. MST means different protocols are there. But in CCNA curriculum, we have to learn, we have to understand about PVST plus, because this protocol we are using the most within the enterprise. Then in that, we have to understand the terms such as root port, root bridge, primary, secondary, other ports, port estate, PortFast, and then the security measures such as root guard, loop guard, BPDU filter, and BPDU guard. So these are the topics that we have to learn, understand, and perform the lab task today. As you know that we have the topology, so I haven't added the topology here, but we have the topology where we have 3 switches connected, switch 110, then switch 101, and switch 102. So we have triangle type of topology where we'll go and perform the ether channel first. So let's try to understand the ether channel. Ether channel is nothing but when you are bundling different interfaces ports. And why you're bundling? Because you want more throughput, so you can go and aggregate different type of ports. For example, you can go and aggregate 2, 4, 8, 16 ports together. So suppose if they are 1 gig, then they will be assumed that if you are bundling 2 ports, they will provide 2 gig. If you are bundling 4 ports, they will provide 4 gigs of throughput, vice versa. So logically, you are aggregating the physical interfaces together. That term is ether channel or bundling the ports. Now, while bundling the ports, we have different protocols to do that. In CCNA, we have to learn about the link aggregation control protocol, LACP, which is defined by the IEEE standard 8023AD. This is industry standard. And if you want to read the RFC, you can go and check the standard RFC number. RFC number, I don't know what is that, but this is the standard IEEE 802.380. Now what we are doing, it's very simple, that you can go to the interfaces. You can go to the interfaces, and those interfaces, simply suppose I have 2 switches. And if I want to bundle the ports in between the 2 switches, suppose I have switch 1 and switch 2, and in between, if I have interface 1 and interface 2, I can go to these 2 interfaces together with the range command. You can see below that range command. You can see the range command. And then you can go and run the command like interface range. First of all, go to the interface range command, and then channel group. What's the number you want to assign? 1, 2, 3, 4, 5, 6, 7, whatever number. Mode active. Now, when we are using LACP, then you will see options related to mode active, mode passive. So you can use either active or passive. If you are using active passive, that means if you are using active both sides. So if I go here and use active and active, mode active and active, then they will form the ether channel. If I go and use active and passive, then they will form the ether channel. But if you go and use passive and passive, then they will not form the ether channel. So one side should be active, other side may be active or passive. That's the requirement for LACP to bundle the port. Now, in case you don't want this LACP to be used, then we have a static method. When you are not using the protocol, then you can go and use the static method as well, right? And with that static method also you can go and bundle the ports. So in that case, what you need to do, that you don't want active, but you want the static method. So here what you will do here, mode on, you can see mode is on. So other side also you will make the mode as a on. So both side you will make mode on and on. If you do on and on, that will also form the ether channel bundle channel. So like that, we are going to see the example today in our lab, that few of the interfaces we will go and use. So here you can see the topology that we have, that here I can go and use LACP in active. Here also I'll make active, here also I'll make active. Here I will go and use active, and here I will use passive, just to show you active and active passive in action. And then here I'll go and use mode as a on. Like here we'll not use LACP, but we'll use the manual method to do so. Now this ether channel, you can see the topic. The ether channel also can be layer 2 ether channel and layer 3 ether channel. Layer 2 ether channel, layer 2 means it will understand the MAC addresses, frames. Layer 3 means that you can go and assign the IP address. So you can see here in this example, if you go to the port channel, make it switch port. Switch port means layer 2. Then you can make this as a mode trunk, and then you can allow certain VLANs. So you can allow VLAN 10, 20, 30, etc. This is what? This is the layer 2 ether channel. But if you go and use command no switch port, and if you go and assign the IP address to the ether channel, that will become the layer 3 ether channel, right? That will become the layer 3 ether channel. So these things we have to learn and understand. So what is the agenda? That you should go and create active. First of all, within LACP, we'll go and create active and passive. Then manual method is there. Manual method is on, and then the ether channel having L2 mode and L3 mode. Like that, these are the topics that we will go and understand. So let me go quickly to the topology that we have, and let me pull the lab that we have. I can see the lab. Let me close this. The switches that we have in the lab, right? And parallelly, you can see the interfaces as well. So I will go here. And first of all, I'll make this default interface. I know that so many different configurations are there. E1/0 to 1 shard, just to make sure that I have my interfaces working properly. And then since switch 110, I want to make channel group, suppose 1, mode active. If I type question mark after mode, you can see that you will see options related to active. This is LACP active. And then you can see option related to auto. Auto is for PAGP. For PAGP, we have auto and desirable. That is Cisco protocol. That is only understandable over Cisco devices. But LACP is industry standard. That multi-vendor, they are supporting LACP protocol. So we have option active and passive. And if you want to make it manually, you can go and use the option called on, right? So here I want to make this as an active, then other side. So this side, what interfaces we have? E1213. So I will make the default for interface E1/2 and E1/3, and then interface range E1/2 to 3. channel group and the number, suppose 2, mode suppose active. So both side active, active. So this side also active and this side also active. So both side I am using active, active. Then let's go to the switch 101 and what interfaces we have there. Also we have default interface E1/2. I know E1/2 and 3, and interface E1/2 no shut 1/ means you do shut no shut. So interface range E1/2 to 3 shut and no shut. And then we'll go to channel group 1 mode. Here you can give active, no problem at all. Once you do this, and then you can go to the switch 10110, you can do show EtherChannel summary. It will tell you that the ether channels that you are creating 1 and 2, right? 1 and 2, one with 10 and 11, it is showing down. We'll go and check why it is down. I will expand this diagram and I'll show you that, but let me go and configure all parts. So then let me go and make the default for interface, these interfaces. What interfaces? 20 and 21. Just I am removing the configuration. And here channel, so I should go to interface range E 2/021 shut no shut. Channel group, suppose this is 3. This is mode on. What we want here? Here active. This is active. This is also active. Here we are giving mode on, and here we will give the passive mode. So we are done with the configuration. Switch 101. Let's go here and default the interface E1/2 1/3 interface range E1/2 to 3 channel group, or that 1 to 2 mode passive. And likewise we'll go and default the configuration for 2/021. We'll go to the range 2/021, and here we have channel group 3 mode is on. Now we have done the full configuration. Let's see. Let's see all those configurations. So we'll go to switch number 110 and we'll do some troubleshooting why it is not coming up. Do show ether channel summary will tell you this story. So here you can see that SD. S means what? S means capital S will layer 2, switched layer 2. And then D for down, D for down. So here it is the status is down and this is small s is for suspended. So both the port channels, they are down at the moment. We'll go and see why they are down. So you can do one thing, interface port channel 1, you can do shut no shut. Even you can go and check the port channel configuration. So it is telling that port channel 1 configuration is switch port trunk encapsulation dot 1Q mode trunk. Now this configuration should be same in both the places. Is there? Here also I'll go interface port channel 1, shut and no shut. Oops, no shut. I just bounce the interfaces and then we'll go and check the port channel 1 status. So now it is telling that you are in the suspended mode. Earlier it was in the down mode. Now it is telling that you are in the suspended mode. So why it is suspended? Let's see. Do show run interface E1/0. Let's see the configuration. for these interfaces, 1011, mode active, and let's go and see the configuration. 1/2 and 1/3, right? So configuration wise, it is okay. Configuration looks good, and port channel configuration is also okay. Seems everything is okay. Let's quickly check the physical interface. Do show interface E 1/0. Physical interface should be, see, line protocol is down. So physically it is down actually. Interface range E 1/0 to 1 should be up. So what it is telling that E11 is not compatible with port channel suspended. Port channel 1 is .1Q is not compatible. So it is throwing an error. It is telling that your interfaces, switch port mode trunk, switch port trunk encapsulation .1Q. Right, and then let's see if it will throw no error. Do so EtherChannel summary. Now you can see waiting status. So you can see different states as well. It is waiting, and here it is suspended, or it will be down, right? So now it is suspended. Why? Because the remote port, LACP currently not enabled on remote port. Why? Because from the remote side also you should have this configuration over the interfaces. So I can go to the remote interfaces. I can go to these interfaces. What interfaces we have? Interface E, interface range E 1/223, and I can go and assign these configurations. And now if we go back here, now it is telling that your port channel is up. So now you can see that layer 2 up, SU, layer 2 up, port channel is up. But you can see that it is not up to the port channel 2 is not up. So for port channel 2 also, we should have the same configuration that we have over the member interface. Same configuration should be there over the port channel interfaces. So if you go and check interface E1/2, you have this configuration. So go to the range and push this configuration, right? And here, go to the range, push this configuration. And now you can come back here and you can check the EtherChannel summary. Now you can see your port channel 1 and 2 both are up, but they are layer 2 at the moment, right? They are layer 2. What we need to do, we have to bring up one more port channel in between 101 and 102. So we'll go to interface range E 2/021, and there also I should go and push the configuration related to trunk. So where it is, the trunk configuration here, this should go and put this configuration. And here also interface range E 2/021. And now if you go ahead and check, do show EtherChannel summary. So now you can see now you will see that port channel 3, you can see no protocol associated. Why? Because this is running as a mode on. This is where we are doing the manual work, right? This is where we have given the command, the channel protocol number 3 mode on. So that's why it is not showing any protocol here. So now we have the full-fledged lab where successfully we have converted all the member links. All the member links we have converted into the port channel. Here you have used method active active. Here you have used method active and passive, LACP active and passive, and here no protocol, no dynamic protocol. Here we are using the mode on both sides. So we have done the layer 2 port channel. Now you can see in layer 2 what we have to do, we have to go to the port channel. You have to make this switch port trunk allowed. Same thing we have done here. Same thing is there. Actually our example is very much layer 2 port channel example, right? Why? Because interface port channel, if you see this, it is actually switch port mode trunk layer 2. Only command I can go and give say port channel 1 switch port, right? So one side if it is a switch port, inter switch port. So this is very much layer 2. And then if you have multiple VLANs, you can pass over this interface. So if I have multiple, say interface port channel 1, switch port trunk allowed VLANs, say 2000, 2001, should give comma 2001. So you can do this. And this command you should go and give to other side as well, right? So this is acting very much as a layer 2 port channel. If you have layer 3 port channel, so suppose port channel 2 if I want to make as a layer 3, right? So no switch port, and then IP address 192.168.1.1.252.0, and likewise I can go other side what is the other side connectivity, port channel 2, this side actually 102, port channel 2, no switch port, IP address 192.168.1.2, like that. And now port channel 2 you converted as a layer 2 port channel. So you can go and check the Ethernet summary here. Now you can see, although it is down, but it's okay. R stands for what? R stands for it stands for routed. It stands for layer 3. So now you have converted this as a layer 3 port channel, right? So it is converted to layer 3. And if you go and see, oops, and oops, not port channel 1, port channel 2. And if you go and check it, do show run interface E 1/2 and 3. So do one thing, interface range E1/2 to 3. And interface range E1/2 to 3. Member interfaces should also be no switch port. And now you can go and see the EtherChannel summary. Do so Ether show LACP. LACP commands are also there that you can go and explore on that. Internal details, it will tell you the detail about all the ports, their MAC addresses and priority and all those things. Okay, so when we are creating the layer 3 port channel, you can see that for layer 3 port channel, no much configuration needed. You can go to the interface, make this no switch port, and it will work as a layer 3 port channel, right? So that's the configuration we have. If you have any question, please feel free to ask. E1/2 to E1/3. Interface range E1/2 to 3 were already there. Shut. Shut. Slash. Share interface port channel 2. EtherChannel assembly. Channel group 2. I just want to show you that this is up. So what I have done, that I have converted this layer 3 memory interfaces as a port channel, manual port channel, and then the interfaces are coming up with LACP. Those layer 3 interfaces, they are not coming up. Okay, so we have completed this task. This is a big lab that we have completed. Although the number of commands, they are very less, the lines of configuration very less, but we have completed that. If you have any question, please ask. All right, no problem. So let's move to the next topic that is related to spanning tree. One good thing about a spanning tree is this, that at the moment you will go and create the VLAN. At the moment you'll go and create the VLANs to these switches, spanning tree will come automatically. So you don't need to go and enable a spanning tree over the switches. By default, they are running. So what I'm telling here, if I go and create VLAN 2000, VLAN 2001, and if I go and check show a spanning tree, you'll see that spanning tree is running here. Spanning tree is running here with respect to VLAN 2000. VLAN 2001 also should be there if it is created 2001, right? So you don't need to create it. By default, it will start running. What you can do, that you can go to the switches and you can change the mode of a spanning tree. So as per our blueprint, we have to learn about rapid PVST plus, rapid spanning tree PVST plus. And again, I told you that there are different versions of STP which is there. In this session, we have to understand about rapid PVST. So I will go and focus on rapid PVST, and what we will do for VLAN 2000 and 2001, we'll make switch 101. So assume that our switch 101 is the root. So what is happening in case of a spanning, that you have to go and select one root bridge. So suppose in our case, we'll go and take example that switch 101 is the root bridge for VLAN, 2000 and for VLAN 2001 as well. Now, by default, as per the MAC address and the priority, these triangle switches, they will go exchange their BPDUs and they can go and select the switch port, right? Switch root bridge. They can go and select the root bridge. Who is the root? Who is the owner of a spanning tree in this topology, in this network? So what we'll do in our lab, we'll go and make switch 101 as a root bridge. The parent is the root bridge. Now, whatever switch we have, which is next in the line. So suppose switch 101 is next in the line. So that will become the secondary route. So this will be the primary route and this will be the secondary route. But it's very interesting that whatever ports that are going towards the root bridge, they are DP, designated port. They are DP. So from this path, you'll see that from this path, it will try to reach to the root. So that's why this is DP. From here, you want to reach to the root. So you are the DP. Right. And I hope that I'm correct. I need to check this. Okay, 1 second, just a second. Let me go here. So we have to understand the topic related to root port, root bridge you understood, right? Primary and secondary root bridge, MAC address into the priority. I will explain you about the priority as well. So there are different spanning tree. You can go and use the command spanning tree mode PVST. I will do in the lab as well. We have to go and change the mode as a rapid PVST to all these switches. We will do that. The protocol is IEEE 8021W. Yeah, root bridge. I'm more interested in the designate. I haven't added any diagram here. I should go and add. Oh yeah, I haven't added in the diagram, but I have mentioned here in the notes here. So suppose, okay, so in this notes, what I have done, I have make switch 110 as a root bridge. So, okay, no problem. Little bit change in the topology. Suppose this is my root 110. I'll make 110 as a root. So if this is the root, you can see the theory here. If 110 is the root, all ports are the designated ports since this is the root. Okay. Okay, got it. So here is the analogy. So this is my root bridge, right? And make this, think this as a primary. I'll make this as a primary. And this will be my root bridge. But this I'll make as a secondary. Okay. So primary and secondary as per the MAC address into the priority. They are making that. So now what I'll do, see if this is a root, this will become your DP, designated port. So whatever root bridge you have, those ports are designated port, and near to or adjacent to designated port, they are the root port. These terms, they are not that much significant, but just for understanding, root bridge, all ports related to root bridge, they are DP, and the adjacent port to DP, they are RP, root port. Now here is the twist. So since this is your secondary port, and from here you can go in this direction, so this will become your DP, and this will become either your alternate or block port. So these are the port significance you have. If you go and check the nodes here. So root bridge, your switch 110 as per the priority and MAC address, they will be the root bridge, root port. The root port is the lowest cost part to reach to the root bridge, lowest path cost to reach to the root bridge, like this. So these are the root port, these are the root port. Then designated port is the port on each segment that is the lowest path cost to the root bridge. This is responsible for forwarding the frame. Actually, designated ports are near to the root port. You can see this is the designated port. Why? Because this is secondary. We can reach from here to here with the lowest cost. And then you have the alternate port. Alternate port is the backup port. So you have the alternate or blocked port here. If something will happen with this port, if this is down, then traffic may go in this direction, like in this direction, or it may go in this direction. This is down, so it may go like this, like this. So this blocking port will come into the picture, or alternate port will come into the picture. So these are the rules actually. It's very much that if you draw the diagram, and from the diagram you can go and understand the roles of these ports and how these ports are getting assigned. It is explained here as well. Switch 110, the port connected to 110 is the root port. So this is the root port, right? And this should be the designated port. So it will explain you here that it is connected either designated or alternate, but as per the cost, this will be the designated port. And then finally, this explanation. Okay, so I will go to this particular listening learning mode. I'll explain you about these port status, but these port status are very much when you are running the normal STP. Normal STP. By default, we have spanning tree protocol which is running. So if you go to this spanning tree protocol, which is running by default, what happened to my lab? Okay, which is running by default, and if you do show a spanning tree detail, so here you will understand, even you can see designated port and port priority. I'll explain you everything here. But if I do brief bridge, okay, let me show you this. I'll explain you everything here in the diagram. In my case, what I will do, first of all, let me make this. I can go here and I can create, I have two VLANs, right? VLAN 2000, 2001. Likewise, I'll go and create two VLANs here as well. VLAN 2000 and 2001, and VLAN 2000 and VLAN 2000. So all the switches having VLAN 2000, 2001, right? Okay, great. And now let's see, show spanning tree. Where is that? So spanning, okay. Let's see, do show spanning tree for VLAN 2000. So for VLAN 2000, you will see that STP is running. This is the priority 3476 by default. This is the MAC address. So MAC address into priority will give you the root bridge. So they will elect the root bridge as per the MAC address into priority. So they are telling that this is not a root bridge, but this is the MAC address and priority, and this is the MAC address and priority of some other switch, which may be the root bridge. So what we can do here, simply see, spanning tree. First of all, let me go and run the rapid PVST because that is the requirement. This is the requirement that switches should run the rapid PVST as per our syllabus agenda. Now, if I go and check, you can see, now we are running rapid PVST. Now what I can do is spanning tree VLAN 2000 and 2001 priority 0. 0 is the lesser priority. You can't go less than 0. Now you will see that this bridge is a route. Why? Because priority we have reduced. Now the earlier it was some 3768. Now it is showing 2000. This is the less priority in all these three switches. And that's why you can see the MAC address here, MAC address here. Why? Because this is the priority. Why it is coming 2000 here? Because of this VLAN. It is adding the VLAN number here. But this is the main thing here. This is the root bridge. Likewise, we can go and check VLAN 2001 for 2000. Here you can see 2001. Why? Because this is VLAN 2001. So it is adding this number. Priority plus VLAN plus the MAC address will give you the root bridge. So this is the root, right? This is the root. It's very easy, right? While giving the priority, it will become the root. Now, if I want that 101 will become the secondary root. So here I can go and give a spanning tree VLAN 2000, 2001 priority. If I type question mark here, priority may be 0 to this 61,000, an increment of 4096. So if I give 4096, a spanning tree for VLAN 2001 or maybe 2000. So now you will see that even I have given the priority 2000, still it is showing 2000. Anyways, no problem. But MAC address, you will see it is not the root. You can see it's not the root. And if I go and show you here, see, still this is showing the root. It is showing this is the root bridge. But if you go and see the other details, say so spanning tree bridge, I can see here the VLAN 2000. What priority we have set? 4096, 409. This is the VLAN, this is the VLAN, this is the MAC address, this is the MAC address, protocol, RSTP, RSTP, RSTP. And now here you can see the forward delay, the MAC says. So there are timers related to this. Once you go and enable the status, the port status, they will be in the listening, learning, and forwarding. In normal STP, listening, 15 seconds, learning, we can check that timer, 15 second, and forwarding should be 0 second, right? Immediately it should forward. And then there is blocking as well for 20 seconds. That means that overall, so suppose if one port, I have one port, and if that port is in blocking state, so from blocking state to come to forwarding state, from blocking it will move to listening, then learning, and then forwarding. So that's why the total time here will be 50 seconds. But that is for normal. That is for normal spanning tree protocol. Listening, learning, forwarding, after blocking, it will take 50 seconds in the normal mode. But if you are running rapid PVST, then you can see RSTP, per VLAN rapid PVST plus. In that case, it will be fast. It will not wait for 50 seconds. That's why we are using this rapid PVST methodology to improve the STP convergence timing or timers. So I have added this states of this. I haven't added the listening of 15 seconds because rapid PVST, they have learning, forwarding, again forwarding. So forwarding the frame, it has less than 50 seconds. The timer is less than 50 seconds. Normal traditional STP, they have, you can see discarding or blocking. Blocking for 20 seconds, learning for 20 seconds, listening actually, listening, learning for 20 seconds, and then forwarding. Right, so that was that method. Now there is one very important enhancement here, that since this is your topology, do you want that you run the STP on this interface? where you are connected with the laptop or workstation? No, right? You don't want to send the STP BPDU, Bridge Protocol Data Unit, BPDUs to this interface, right? You don't want to run the STP on this interface. So that's why these interfaces, we are making them as a PortFast. PortFast means that they will not go in these phases, listening, learning, blocking. You are not sending any BPDU. The interfaces where you are connecting the laptop or PCs, you're making those ports as a PortFast. So directly they will forward the packets. They will not go to blocking, listening, learning states. And that is one of the enhancement we have in the STP, that you are not going in the different states of STP, but you are directly sending the packets to those interfaces, right? That's why we are enabling the PortFast. Now here is the summary chart. You can see what's the root bridge, what's the root port, what is the designated port, alternate port, and the port status like learning, discarding, learning, forwarding, right? This is the summary chart we have. Now after that, we have some security measures that I will not cover today because this will become too much for today's session. So we can go and stop here. We have done lots of hands-on, and then we try to understand the spanning tree protocols as well. So you please go and watch this recording and try to simulate the lab that we have done today. Try to perform the lab with both EtherChannel, like LACP and manual, and try to do with the lab related to STP as well, rapid PVST, both you try to do it. Thanks for joining. Today we will discuss about these topics that you can see here, these listed topics. But before doing that, let's go and see that we have some security topics that we were discussing earlier. First, I will go and complete a root card, why we are using root card, loop card, BPDU, and BPDU filter. You can see that I have created nice comparison table as well. This table will help you to understand these technologies. Before reaching to this, let's go here and understand these technologies. Okay, so what is root guard? Here you can see root guard is a method that will prevent a port from becoming a root port, right? So what will happen in the technologies that we have, that rapid PVST and STP and all those? Here you can see that diagram. Suppose this is the root. If this is the root, right, root bridge, then this will be DP, designated port, and this will be the RP, that is root port, right? Now what this technology will do, that it will prevent to becoming root to the other switches. So this switch will not become the root. The question here is this, that how this switch will become the root. Now this switch will become the root when it will get some superior BPD, or in other words, you can say that if these devices will get BPDUs, Bridge Protocol Data Unit, that have lower MAC address and a lower priority, or lower priority and MAC address is the second thing. First, they are deciding basis on priority. So if these switches somehow they will get information related to the priority, related to the lower priority. So this switch will announce itself that, hey, I have lower priority, hey, I have lower priority, irrespective that in your network, this is your root bridge, right? So to prevent from that, to prevent from this happening, that other switches which is non-root, they will try to become the root. You can go and use this configuration. So you are not expecting that over this interface, I should get some superior BPDU. So you can go and use this guard root. Protect the root switch. The command is guard root, spanning tree guard root. So it will go and protect the root switch, right? Then you can see same way you have the loop guard. So you have the root guard and then you have the loop guard. As the name suggests, loop. That means that this technology will prevent from the loops. How? So here you can see loop guard prevent an alternate or root port from transitioning to the forwarding state. So what is happening that if you have 3 switches, and this also we have discussed earlier. Let me try to draw here. So I told you earlier that in the topology, if you have switch 1, if you have switch 2, if you have switch 3, and if these switches have the connectivity like this, and in this election process, if this is the root bridge, right? So that means that any port that is going towards the root bridge, that will be root port, and the adjacent port will be designated port DP. So that means this will be the root port and this will be the DP. Now, if it is the secondary root bridge, then this will become the DP and this will become your alternate port. Alternate port, that means that it is type of blocking port, but condition here, you can see the condition. The condition here is this, that if your alternate port, mainly alternate port or root port, prevents transitioning to the forwarding state. So suppose this is my alternate port, right? And if it will try to listen or send BPDUs, so this configuration, the guard loop will go and protect from that. So if it is alternate port, it is not assume, it will listen 100%, obviously it will listen. It will take the BPDU over these interfaces, but it is not assumed to send the BPDUs. It is not assumed to send the BPDUs. So in those cases, we can go to this interface and run this command guard loop. So you are protecting from the loop that your alternate port, they should not send the BPDU frames. Right. Next two mechanisms are actually very straightforward, that you want to filter. You want to filter the BPDU, bridge protocol data unit. So if you filter the bridge protocol data unit, what will happen? Let's see. There are two technology. One technology that should work with the PortFast. So if I have, BPDU guard, let's start with BPDU guard. So BPDU guard disable the port if a BPDU is received. Typically, it is used to configure along with the PortFast. So suppose that in this diagram, if I have one PC connected here, and this particular interface that we have enabled the PortFast. Why we are enabling the PortFast? PortFast interfaces will not go in the STP states, listening, learning, blocking, listening, learning, forwarding, etc. It will be in the forwarding state always. And if this port is PortFast, so you are not assumed to send the TCN, topology change notification, or BPDUs. You are not assumed to send the BPDUs, because why you will send the BPDUs? Because this machine will never take part in the spanning tree elections. So you should not send the BPDUs over this interface. So what you can do, you can go to this interface and you can enable BPDU guard enable. Right. So this is coming with along with PortFast. Protect from the BPDUs. Now we have one more feature added, BPDU filter. BPDU filter simply prevent sending or receiving BPDU on a port. It can be useful on ports connected to the end devices with HCP. Same thing you can see. BPDU filter is also the same thing. on those interfaces where you are assuming that those interfaces should not take part into the STP election where you are enabling the BPDU filter. Then what I have done, I have created this comparison slides. You can see PortFast, root guard, loop guard, BPDU filter, and BPDU guard, just for your reference. Okay, if you have any question, please feel free to ask.
No, for me.
All right, so let's start our day number 9. Day number 9 topics that we have. Day number 9, you can see that we have the topics. Few of the topics are related to wireless technology, and then few of the topics that is related to network management. So we will learn those topics one by one. Wireless architecture. So 2.6, understand the wireless architecture and AP modes. Then describe the physical infrastructure and connectivity within these wireless network like AP, WLC, access trunk ports, and the lag feature that we have. Then device management. And then obviously I told you earlier that 2.9 we will do later when we have the wireless lab. So I will go and hit 2.6, 2.7, and 2.8 today. Let's start. Understanding the architecture. There are two pieces, right? One is your WLC, wireless LAN controller, and one is AP, access point. Now, with these APs, the wireless devices, they are getting SSID, means they are getting connected. And to manage these APs, you need some controllers, right? So let's understand the architecture of controller first, and then we'll understand the architecture of access point after that. Wireless architecture, the LAN controller architecture, it may be centralized. You may have flex connect. This is very interesting and widely used. You may have a distributed mode. You may have cloud-based controllers, or you may have converged access. Centralized, what is centralized? That means you have one WLC in HA that is centralized controller for all the locations. So AP connects to the central WLC. But we have this option called Flex Connect as well, where the AP can switch traffic locally to maintain while maintaining communication with WLC is something like local management. And this is one of the features that we have in the WLC itself, that you want to configure WLC in Flex Connect mode. So in that case, you can think that your WLCs will provide some brain, like, some control to APs as well. Generally, the control traffic, generally the manageability that you have, that is with WLC. So suppose I have WLC and suppose I have two APs. Suppose these are the APs, right? So these APs, they are working as a data plane device, but the whole brain that we have is obviously with the WLC. Now, if you go and give some sort of intelligence to these APs, so you have to go and convert that into Flex Connect mode, right? Then distributed, distributed means that you have WLCs in one locations and WLCs in other locations, and then they are working like in a distributed manner. So AP can operate autonomously, cost effective. Yeah, obviously it is cost effective because you have the distributed design. Cloud-based means you are using the cloud controller to manage the APs controllers. One of the example for this may be Cisco DNA. One example is Cisco Meraki as well. Cisco Meraki, they are cloud managed platform, and you will get one portal from where you can go and manage the wireless Meraki devices. Other example may be Cisco DNA. If you have Cisco DNA over AWS cloud, so now we have the DNA flavor for cloud as well. So cloud instance DNA you're running, and from that you can go and manage the WLCs and APs. So that may be cloud-based. Then converged access, like integrate wired and wireless network, we'll see that converged access and the connections. It provides unified policy and the management. So these are the modes we have related to WLC. Related to, you can think as a control plane. Control plane can be centralized, localized, distributed, cloud-based, and converged access. Next, we have the access point mode. So access point can work as a local default mode for serving client and monitoring air quality. Local mode, flex connect when they have the intelligence, when they have some of the intelligence that you are providing from WLC to AP. So they can work as a flex connect mode. They can work as a monitoring mode. They can work as a sniffer mode just to capture all the wireless traffic for analysis, or they can work as a rogue detector mode, focus on detecting rogue devices through the wire traffic analysis. These are the modes we have in the access point. Generally, it is working as a local mode or flex connect mode. These two that we are using widely. Flex connect is also very popular nowadays. Generally, it will work in a local mode, means centralized connection, or flex connect. These are the two widely used, even they're distributed as well. These are the three design that we are using. And if you are using Meraki, obviously cloud-based management you have. So even you have these four WLC design widely used, and then you have the local mode and the flex connect. Sometimes we are enabling the rogue mode. In that mode, the WLC, they are detecting the APs, but APs are there just to analyze the traffic, right? There are more you can see. You have bridge mode. Actually, you have to go and enable this mode. You have to go to the API and you have to give the command that you are working as a bridge mode, establish wireless bridge between the network. Then we have the bridge plus flex mode. And then we have mesh mode. Bridge plus flex, bridge means that you are bridging between the network, and the flex means you have the intelligence, local intelligence. So you have the brain and you are working in the bridge mode. Then we have SE connect mode, spectrum analysis and troubleshooting, just for troubleshooting. And then finally mesh. This is also important mode, and if you study for some CCI wireless and some higher end wireless courses, so you have to go and configure the devices, the access point basically in mesh mode, so they will not leave any gap in the air like that for extended coverage. So these are the modes we have related to AP. And then what I have done, I have presented the nice table for all those, first of all, related to wireless architecture, and then related to AP mode. So part one, local mode, flex mode, monitor, sniffer, rogue detection mode, bridge mode, flex plus bridge, AC mode, and mesh mode. So once you know little bit basics of the architecture, then you can see that we have the connectivity. We have to understand the connectivity. So CCN exam is exam task is this, that you should understand the connectivity in between the WLCs, switches, APs, access point, and workstation. So let's try to understand this. Suppose you have your core switch cluster. Let me write as well how connectivity look like. Suppose this is my core one. It may be Nexus, it may be non-Nexus. If it is in data center, then Nexus. If it is in branch, then it may be some high-end switch. Now with this core, we are connecting the WLC because this is your centralized location. So we are connecting a WLC. your controller. WLC controller, and then below this architecture you should have the distribution layer and access layer. So we have this type of connectivity. This is my wired structure, wired LAN type of a structure. Like this, you have the connectivity. Like this, you have the connectivity. So then here you have your distribution 1, distribution 2, and then you have your access 1, access 2, access switch 3, etc. Now with this access switch, obviously you will go and connect what? Connect the APs. So I have my APs connected. Suppose AP1 and AP2. Suppose we have the APs, the antennas, right? So here you can see that you have the wired backbone. So far everything is connected with wired backbone. But when these APs will go and connect with the PCs or laptops or mobiles, then the frequency should be wireless, right? Dotted line for wireless. So then you have the connectivity with the laptop or the handheld devices. So this will be the architecture for your wireless network design, where you have AP1, AP2. So let me write here AP1 and you have AP2. Here you have to understand the connectivity. So what type of connectivity we are using here? Obviously here you will go and use lag. What type of connectivity you have here? Means what type of mode is it access, trunk and all? Here what type of connectivity you are providing here, right? Because after that everything is wireless. Then behind the scene, the communication channel that we have in between the APs and WLC, they will go and form some cap-wap tunnel. This will be your control connection, right? Because here what you are exchanging, the control packets. In between APs and WLC, you are exchanging the control packets. And here, suppose if this PC will communicate with this PC, so it can be done locally. Means data exchange obviously will happen locally. From one network, you will go to the other network. Or suppose if you are using internet and all, then you can go and use the internet, right? From AP, it will go to the gateway, and from there it can go outside. So like that, you have the network, and let's understand that these configuration, these interface configuration, and here even you can go and bundle the interfaces and make the lag as well. So those things we can go and understand. Oh, I have the architecture here. You can see that you have WLC connected with core like this. Then you have the access switches, means I have created distribution and access. It may be collapsed core where you have distribution and access in same layer. And then it is connected with AP, and then you have the workstations. So that's the connectivity we have. Then access point. Access point will connect with the switch, any of the access switch that it is connecting. So where what you will do? Mode access, access VLAN 20, power inline. Never. You can use this or you can leave also, there is no problem. But these two lines, switch port mode access and the VLAN. Then WLC connectivity. So you can see that core switch is connected with WLC, where you are making that as a trunk. So that interface you are making as a trunk. So here you have the trunk. Here you have the access VLAN 10, 20, 30, etc. But over the WLC, what you will do, you will make that port as a trunk, and you can go and pass different VLANs. Straightforward. There is no much problem on that. Then access ports, mode access VLAN, it's okay. Same configuration. Trunk ports, that will go and connect. It depends. So if we have the connectivity in between the WLC, you will make that port as a trunk and you do the configuration, same thing. Now this is important. Link aggregation group. Why we want this link aggregation group? Link aggregation you want because you want the redundancy in between the WLC and the core switches. So to the core switches, you can go and bundle the ports, channel group mode active. You can bundle the port and then you can make that as a trunk and you can pass the VLAN information over the trunk. That's the link aggregation group that we can go and create in between the WLC and the core switches. So you can see that we can go and bundle. We can bundle these ports, and this bundling is termed as a lag, link aggregation group. Same way that we are bundling the switches, the same configuration you can go and use to the WLC side as well. Even WLC side, you can go and use the GUI configuration in GUI mode. And then you can bundle even the CLI configuration is also easy to do in WLC. So you can bundle it. There's no problem on that, right? So that's the summary we have related to topic 2.7. Now we have topic related to 2.8, where we have to do some hands-on exercise. This is the topic related to managing the network, understanding the telnet, SSH, HTTP, HTTPS, console access, little bit of radius and TACACS configuration, and cloud managed management. Cloud managed is something that you are using Cisco DNAC as a cloud flavor, or you are using Cisco Meraki as a cloud services. In that case, you have to just simply go and register to the cloud. You don't have to do much things for cloud management. Register to the cloud. You should have some username password. You can go and log in. That's it. Easy, straightforward. Now let's discuss about this telnet SSH. Telnet is a service that you can log into routers or switches. So if I have routers or switches, then these are obviously, so let me do one thing. Take our example. So what we will do today, that we will go and connect two switches, switch 110. Let me go and connect this. I'll go and connect two switches. Say switch 110 and then switch 101. They have the connectivity over the interfaces, right? And then if you want to telnet, from 110 to 101, how we can telnet? If you want to SSH, so what is happening that these telnet and SSH, we are defining some line VTY, virtual terminal access, that TY, virtual terminal 0 to 15. So you have different lines VTY that via which you can go and log in with local database, or you can log in with some AAA credentials like logging, authentication, authorization. Those type of commands are there. We'll see that if it will come, I'll explain you. But at the moment, log in with the local database. For this local database, I'll go and create username ABC, password BCD, like that. You can go and create. I will explain you in these slides. So here, while you are logging, you can go and give the transport input as SSH, or you can go and give the telnet, not only input, but output, transport output as well. It may be SSH, telnet. We know that telnet is not a secure protocol. So in production network, you will not see telnet is enabled over the interfaces. You will always see transport input SSH, transport output SSH, secure terminal, secure cell, right? So we want to log into the device securely. So for that, telnet and SSH will be used like remote login or login to the devices. Then what about HTTP and HTTPS? So nowadays these devices, these routers and switches, they are very intelligent. They have some APIs enabled. They have some good software within those systems, and they can, for example, Catalyst 9000 switches. There you can go and create the virtual images as well. You can go and do some app install as well. So those devices, even Cisco CSR devices, some iOS XE devices, those devices, nowadays you have GUI access as well. You can log into those devices via GUI as well, in GUI mode as well. So for those tasks, you have to go and enable the HTTPS services. HTTP, you know that normal hypertext protocol, and HTTP is the secure version of HTTP. That again, you can use these protocols to log into the devices. Now, one other is console access. Console access is that all the routers and switches, they have something called console port. Directly, you can connect to the console port and you have the access. Now, you can create policy with AAA and others to do not provide default access to console, but by default, you can connect to the device with the console port and you have the access to that device. Then finally, to create some policy related to accessing the device related to HTTP, HTTPS, telnet, SSH, we can go and create the policy based on the TACACS plus and radius plus. These are the way that we are creating the policy, staticus and the radius, right? So let's understand and learn and perform the lab task related to all these features one by one. So let's start with telnet. How we can configure the telnet? You can see that I can go to the switch, line BTY, password Cisco, login local, transport input telnet, and then we can log in from the other device. So let me pull the server here. And okay, I can go to this switch 101. Say, first of all, we should create some username. So username, for example, username Cisco, privilege 15, password is also Cisco. I should see this password space Cisco. What I have done that I gave this command. Oops. Username Cisco, privilege 15, password Cisco. Now, say line VTY 0, you can see 0 to 4. I have 0 to 4 only, the last number. And I can give the password also to this line. Login, I can do local as well with the local credential, and transport input, for example, telnet. Now I should have some management IP. Show IP interface. Some IP is there. Maybe this IP. Let me try to ping first. Oh, so this IP is, anyways, this is access switch. Okay, so what interfaces we have? Let me go and configure some IP addresses over the interfaces that is connecting with switch 110 and 101. They are connected over the interface, so you should go here and default some interface E1/0 and 11 and E1/0 and 1 shut. Suppose 1/0. I'll go and give some IP 681.1.255.255.255.0, and there also I will go. This side the interfaces are default interface E 1/2 and 1/3. We have E1/, for example, 2 shut, no switch port, and then I can go and give the IP, for example, 2. Oops. 255.255.255.0, just the IP address like this. And then let me try to ping to this IP. From here, if you use do command, you can ping from here as well. So I have the IP reachability. So now what I will try to do, telnet is asking username Cisco, and you can see that from switch number 110, we are within the switch 101, right? That's the way telnet will work. Simple, easy, straightforward. Let's move.
I have one question there.
Yeah.
On the, you can go back to the other slide. Yeah, on the second line, the ETY04, that means that you have 4, or I
Five.
mean 5.
5, yeah.
Yeah, 5 available connection.
Yeah.
So that is like the default, or you can change it, like you want to secure more your environment, you can put only like 1.
Yeah. So we have that option that we can do line VTY 0 to 1 or maybe 0 to 0. 0 to 0 is not possible. 0 to 1.
0 to 1.
And then here 0 to 1, I'll give transport input as a telnet. But from 1 to 4, I can give transport input none. You can see none is there, no protocol, all SSH. So we have these options that we can turn off none. So section line, you can see that where is 0, where we have this configuration, then 1 to 4 none. So that means
Okay.
from here I can telnet, but if some other device will try to telnet, then it will block.
Yeah, I would put there, right? Okay.
All right, so let's see the next mode that we,
And another question, just that we are there, about the privilege, the 15, that is a default from Cisco, or what mean 15 there?
we have total privilege from 0 to 15. 15 is the highest. So we can go and do some role-based access control to these. If you provide privilege related to 0 to 1, then you don't have the configuration rules and all those things. 15 means that you have all the access to configure the devices, and that is not a good feature. So we can go and provide security in terms of role as well, in terms of privilege level as well.
Okay, yeah, got it. Thanks.
Right. So next you can see that we can go and use SSH. Why? Because Telnet is not a secure mechanism to log into the devices or access to the devices. So for that we are using the key method. So if you go and create SSH, then you have to go and give the domain name, you have to generate the key, you have to give the SSH version and then transport, right? So these things you have to do. So what we'll do now, that will go and obviously we have a host name. I can go and give the domain. Suppose cisco.com is the domain name. You have to give domain name, cisco.com. Then you should go and generate the key. While we are generating the key, generally we are generating the key with higher value like 1024 minimum. Script to generate key, I can go and give the modulus as well, say 1024, and then it will go and generate the key for us. And then we can go and give the IPSSH version. That's okay. So what we have done, that we have given the domain name and the host name. According to that, we have generated the key. Show crypto key, my pub key, RSA. You can see this key as well. So it has generated the key like this, right? Then we can go and configure this for SSH. So now I can go to line VTY, say 0 to 4 and transport input SSH only, and login is local. And now if I go here, first of all, see, let's verify the configuration. So now from 0 to 4, we have login local and we have transport input SSH. So that means if I try to telnet, this will not work. So now I have to SSH, and multiple ways that you can go and SSH. You can give the Cisco and the 192.168.1.2 like this, username and @ the IP, or you can do like this -L Cisco, and then password we know that is Cisco. Now we are within the switch 101, but this time the user that is coming is via the SSH. The session that we have, that is SSH. If I can show you that, show TCP TCB. So TCP. Actually, it is showing something is in, something is out. I just wanted to show you some summary if I can get. Yeah, VTY is there. Brief. Yeah, I can see this session. From here, this is the port number. This is the SSH port number, and this is the TCB session. So what I can do here, TCP TCB. And you can see the detail about this flag. Okay, so this is the way that you can go and enable the SSH, right? Easy, straightforward, no much extra line of commands. You have to add few lines of command and it will work. Now, what about these features HTTP and HTTPS? Only one line command is there. You can go and enable IP HTTP server or HTTPS server, and this will work. So I can go here and enable IP HTTP server, or if you want HTTPS services, so HTTP secure server, this is the command. Now if you want to test it, You can, oops, we can use the telnet, although telnet is blocked, with port number 80. So if it is showing open, that means you have opened the HTTP services. And if, oops, Control Z, Control C, now you can see that. And if you want to see port number 443 is open, you can see that is open. Even I can go and capture packets here. So debug IP not and debug TCP. IP TCP. Okay, HTTP was there. HTTP. All, I'll do all. Okay. Should show something. See, this is SSL fail, HTTP failed, cryptography, auto negation, etc., etc. Means you can see that. Anyways, the verification. Oops, verification here is this, that this port is open, right? So you can verify this. Console is simply you can connect with the console and it will work. So there is no problem on that. Next topic we have related to configuring the AAA related configuration. AAA related configuration. You know, ICE. Suppose you have ICE server or ACS server, from where you are managing the device access. So in ICE server, you have TACACS policy. With that TACACS policy, if someone will get authenticated with TACACS, then only they can go and access the network resources. If you have such type of policy, then you can go and provide these configuration to your switches and routers as well. So first of all, you have to go and enable feature called AAA, authentication, authorization, accounting. Who is logging, what access level they have, and how long they are logged in. That's the accounting. So AAA new model, you have to enable it. Then in case if you are running TACACS services, so you have to define that what is the ICE IP, ICE server IP, TACACS server host IP and with the key. Then AAA authentication. These are the commands. These are the minimum commands that you have in your switch related to authentication, authorization. Even you can give for accounting as well. So authentication, login, default group, TACACS. If TACACS server, your ICE service is unavailable, then it will check the local database. Local database we have created with what command? Username Cisco, privilege 15, password Cisco. That is nothing but your local database. So first it will check the credentials in the ICE server. Then it will check the local database and then it will provide the authorization. So here again, you can see authorization exact execution. Default is the group that we have created here, the ICE server, and then fall back to local database. This is very much configuration related to the TACACS plus. Likewise, in the similar line, you have other protocol that you can use, that is the radius, that is widely used protocol. So for radius, you can go and define the radius server IP, the key, and same way you can see AAA authentication, login default, group radius local, AAA authorization exact default, and like this, and it will work. Let me quickly go and show you this. So if I am here, and if I go and type AAA authentication or any command, it will not work. Why? Because first of all, you have to go and enable the feature called AAA new model. And once you do that, then you will get all these options related to authentication, authorization, even accounting as well. Right? Long list of options you will get. So suppose you want to do some authentication, simply type question mark and you will get all those options. So authentication, login default, you can see login default. If you have some group defined, you can define. So see, login default. Then I have groups, for example, TACACS and fall back to local. Like was AAA, authorization, exact, default, group, TACACS plus, fall back to local. AAA, accounting, exact, default, group, start, stop, group, TACACS, fall back to. That's it. Just don't have the fallback. Section AAA. So you can go and run these type of commands related to authentication, authorization, accounting. Only thing that you have to go and define either TACACS server, or you can go and define the radius server. So you can define your TACACS, or you can go and define your radius, and it will work as it is. These are the command that is expected at the CCNA level that you should know related to TACACS radius. Although there are long list of commands, there are something like, if you go and log into production switch, if you type show run section AAA, you will get at least 25 to 30 commands related to AAA authentication plus authorization accounting. And not only that, that in case of ICE authentication authorization, even we are going to the interfaces as well, where we are enabling .1x or map features. So for .1x or map features also, you need some 15 to 20 line items, at least 10 line CLI commands to turn that feature on and do some feature configuration related to .1x map. All right, so then we have the cloud manage. It's nothing but you will get one cloud portal. You can go and log into that cloud portal, and from there you can go and manage the devices. For example, dashboard meraki.com or Cisco DNS.com, and from there you can go and manage the devices. It's easy, straightforward. And then the summary. Telnet, SSH, HTTP. We have done the lab as well, and we have checked all those features so far. The last topic for this section is wireless. In wireless, you have to understand, you go to the GUI mode and you configure the WLANs, some security features, QoS profile, and some advanced settings. Either I can log into DNA as well. Even in DNA also, we can do all those things, right? And WLC as well. So I told you earlier that I have a specific wireless lab. So once I log in, I will do all those. So we can do all those things that we have in that wireless. And for that, I have reserved 1 day just to do the wireless configuration. So at the moment, I will leave this section. Once we'll do the wireless section, then I will explain you that how you can go to the dashboard. From there, you can go to the WLANs and you can create, for example, name is 1. You can give the name of the SSID Wi-Fi guest. Then you can go and give the security like WPA1 WIP or WPA1, 2, 3, etc. If you are using WPA2, then you can go and give the policy enable encryption AES method, pre-shared key, or certificate based authentication. Then QoS profile, you can go to the QoS profile and you have option like silver, bronze, platinum. Those type of options we have related to the QoS profile, and the bandwidth option that you can go and give. Then in advanced setting, you can go and give what gigahertz it's supported. It's like 2.4 or 5 gigahertz, and some dual band and some other security features that you can go and provide. We will do this lab later on in the wireless section. Again, this is the example that you can go and set. You can go and set different type of features like QoS, profiles, advanced settings, and all those things. This is just showing you that you can go and set all these features. All right, so we have completed our section 2 as well. Next class onwards, we'll go and start section number 3.